Hello, hi there. Welcome back to this beautiful space for curious learners. A place for those who genuinely wants to explore and master the super subject physics. By the way, I am Shaji, the founder of Shaji'z Physics and our learning community Nucleus, the center of science. And I'll be right here with you, not just as your teacher, but as your friend and mentor to guide you, support you, and to walk alongside you in this exciting journey towards mastering physics. Having said this, I just wanted to check with you whether you have completed all the tasks and assignments given in the previous video or not. If not, please pause this video, go back and complete all those tasks given. Because every step, even if it is very small, matters in this journey. And how you do anything is going to become how you do everything. And you are in this community not just as a casual learner, but as a committed learner. And I wanted to make sure that you are committed throughout this journey. So if not completed, please go back, complete the same, and come back with this video. Having said this, I just wanted to tell you about this specific video. What we are going to learn in this video, we are going to visualize square roots. Is it interesting? You have learned about square roots in mathematics under many situations. You have applied it. But here in this video, we are going to visualize or we are going to check whether it is possible to visualize the concept of square roots. So I wanted to take you to the slideshow, and here we are. Now, the question is it possible to visualize square roots? For that, before going to the real concept, I wanted to give you some basic ideas with the help of which you are going to visualize square roots. That is, here you see a rectangle on the screen whose length is b and height is a or breadth is a. Now, what about the area of this rectangle? We know that area is equal to length times breadth. So the area here is AB square units. If you measure A and B in meter, this will be AB meter square. If you measure A and B in feet, this will be AB square feet. If you measure A and B in kilometer, then this will be kilometer square. That's it. So here, instead of specifying a unit, I have generally given that AB square units. Now, let us consider a special rectangle whose length is equal to breadth, like this, which we call as a square. Square is a special rectangle whose sides are equal. And here we never differentiate length and breadth. Instead, we say simply side of the square, because both the sides are equal. So what about the area of this square? Area is equal to side times side, side multiplied by side, so that we are getting a square square units. Now, can you find any relationship between the side length of the square with the area of the square? Side of the square is equal to a, which is obtained by taking the square root of the area. Root of a square gives a. Then what is a square? It is nothing other than area of the square. So square root of the area gives the side length of the square. Now, we can tell this in the reverse order as well. We already told it, side square is equal to area, or square root of area gives side of the square. These two are the important fundamental or foundational pillars you need to visualize the square roots. So let us check how to visualize the square roots. See here, the question is, why root of 40 is equal to 2 root 10? To visualize this, I am taking a square whose area is given by 40 square units. Now we know that from the earlier or previous relationship, square root of the area gives the side of the square. So in this case, the side length of this square is equal to root of 40. Now, I am going to divide this square into square number of squares. What do I mean by that? I'm going to divide the larger square into 4 smaller squares, each of area 10 square units. See, I have divided it into 4 squares. So now each of these squares are having the area 10 square units. Now, using the same previous concept, square root of the area gives side length. What about the side length of this one? Root of 10. What about the side length of this one? Again, it is root of 10. Now, if you add the side lengths of these two smaller squares, you are getting the total side length, which is equal to the side length of the larger square. So when you add root 10 with root 10, you are getting 2 times root 10. Now, for clarity, let us look into this root 40. We can split this root 40 as root of 4 times 10. Now 4 is a perfect square, which can be taken out of the square, and we can write it as 2 times root 10, which is exactly matching with what we got here. So I hope you got clarity. And with one more example, you are going to get even better clarity. Let us check that as well. So here we are. Here the question is, how it is possible to represent root 45 as 3 root 5? Again, in this case also, I am taking a square whose area is equal to 45 square units. Now, what about the side length? You know it. Write it down. How much it is? Root of 45. Now, I am dividing this larger square into square number of squares. See, in the previous example, we have divided the larger square into 4 squares. Here we are going to divide this larger square into 9 squares, because 9 is another perfect square. So square number of squares. So here, see what I am doing here. This is the larger square, this one same square, but here I am dividing the same into square number of squares like this. So here 9 squares. And what will be the area of each smaller square? 45 divided by 9, which is equal to 5 square units. Now, what about the side length of each of these squares? Root of 5, and the same is true for this and this as well. Root of 5, root of 5. Now, if you add the sides of these 3 squares, collectively, they will give the length of the side of the larger square. That is, when these 3 added together, you are getting 3 times root 5. 3 times root 5. Now, we will cross check whether it is true with the side length of this one. Here it is root 5. We already identified it. Root 5 can be broken into root of 9 times 5. 9 is a perfect square, so that it can be taken out of the square root as 3. So 3 root 5, which is exactly same as this one. Now, the ball is in your court. I have a special task for you. See here, you can try with these 2 examples, root of 32 and root of 75. You try dividing these 2. Consider first these 2 as larger squares. Then you try to divide the square into square number of squares and analyze the same way we did with these 2 examples. I hope by solving these 2 examples, you will get better clarity related to what we have done so far. I hope this is a bulb on moment for you, and I would like you to complete the tasks related to this video. Revise with written practice. Draw the figures, analyze it, think it, brainstorm using that. Practice with the assignments given, complete your notes, and comment your key learnings from this video. So I hope you enjoyed this, and we are going to see in the next video with a new concept. So signing off, bye for now.